Part A is asking us to find the area of the cross-section of the river at Picnic Point in square feet, using a trapezoidal sum with 4 subintervals. The area of a trapezoid is 1/2 times the height times the sum of the two bases. What we will do is we will find the areas of 4 trapezoids to make our approximation. We will multiply 1/2 times the height, which will be the distance from one point along the river's edge to the next, times the sum of the bases, which will be the depth of the water at these 2 points. We find 4 trapezoids to make our approximation, and we multiply 1/2 times height times the sum of the two bases for each one. Once we add them all together, we will find the total area of the cross-section at Picnic Point. In this case, when we use the 4 trapezoidal sums, we find the area of the cross-section to be 115 square feet.
Part B tells us that we can find the volumetric flow by multiplying the cross-sectional area we found in Part A by the velocity of the water at that location. So we're going to use the average value function to estimate the average value of the volumetric flow from 0 to 120 minutes. Average value is 1 over b minus a times the integral from a to b of f of x dx. So we have 1 over 120 minus 0 times the integral from 0 to 120 times the velocity times 115. When you put this in the calculator, you get 120 times 216,860 approximately, and then just simplify. In Part C, we are given a function to model the depth of the water of the river at Picnic Point. It's asking us to find the area of the cross-section based on this model. So we are going to take the integral from 0 to 24, since the river is 24 feet wide at this point, of the function. We put that in the calculator to get our answer of approximately 122.231 feet squared. Part D asks us to find the average value of the volumetric flow from 40 to 60 minutes to see if the water needs to be diverted to avoid flooding. So we're going to use the average value formula again, which is 1 over 60 minus 40 times the integral from 40 to 60 of our function times the cross-sectional area we found in Part C. Simplify and plug the integral into the calculator, and you get approximately 2,181.913 feet cubed per minute, which exceeds the maximum volumetric flow of 2,100 cubic feet per minute. So yes, the water must be diverted.